So for do now number 4, we want to find the value of x that would make line L parallel to line M. So again, if I look at the two angles that are denoted here, those are interior angles on the same side of the transversal. And again, same interior angles on the same side of the transversal are supplementary. So again, I'm going to add them together and set them equal to 180. Okay, combining like terms on the left-hand side, I'll have 21x plus 12 equals 180. I'm going to subtract 12 from both sides, get an answer of 168, and then divide both sides by 21, and x is going to equal 8. Again, it only asked me to find x. It didn't ask me to find the measure of either angle, so I am done. Okay, so two important concepts that we're going to talk about in section 2.4, parallel and perpendicular lines. And the first thing that we're going to talk about is if two lines are parallel to the same line, then they are parallel to each other. So what does that really mean? If line A is parallel to line B and line A is parallel to line C, then that means that these last two lines here have to be congruent. Not congruent, I'm sorry. Not congruent. They have to be, I have the wrong one labeled. Sorry. Duh, it's getting late. Hey, if A is parallel to B as denoted, and if A is parallel to C, that means that B has to be parallel to C as well. Okay, and if two lines are perpendicular to the same line, then they are going to be parallel to each other. Okay, and again, the whole reason that is, if you look at this picture with the red markings on it over here, these two angles are both 90 degrees and they're corresponding angles. And if corresponding angles are congruent, that means that they have to be parallel, line L and line K. So L is parallel to K. Perpendicular transversal theorem. If a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Okay, so what that means, again, if we look at that same picture, I just copied and pasted it and brought it down. So if T is perpendicular to K, as denoted right there, and if K is parallel to L, as denoted by those two little arrows there, then the next thing that has to be true is that T is going to have to be parallel to L. Again, because parallel lines cut by a transversal, that means these two things have to be congruent. They're corresponding angles. So that means that T is perpendicular to L. And that's pretty much as exciting as this is going to get. The right angle theorem states that all right angles are congruent. Again, if you look at the three pictures, all three of those angles measure 90 degrees and all three of them are going to be congruent. It seems like I'm stating the obvious there, but we're gonna start doing some proofs in a little while, and that is going to come up very often. So it's a simple concept, but it's an important concept. Okay, a carpenter plans to install molding on the sides and the top of a doorway. The carpenter cuts the ends of the top pieces and one end of the side pieces at 45 degree angles as shown. Will the side pieces of molding be parallel, and explain? Okay, so what we're really asking is this going to be parallel to this when we put that together. So if I move this piece into here to put that together, the 45 and the 45 are going to end up forming a 90 degree angle. And over here, again, if I put this piece up to that piece and I add those two angles together, that means that that angle is also going to be 90 degrees. So yes, the sides will be parallel because each side piece is perpendicular to the top piece. And two lines are perpendicular to the same line, then they are parallel. So yes, because each side piece is perpendicular to the top piece. And if two lines are perpendicular to the same line, then they are parallel. Right? For example number 2, we want to find what value of x would make A parallel to B. So if A is going to be parallel to B, that means that these two angles have to be congruent because they have to be corresponding angles. And if this one has a little box that denotes that it's 90 degrees, that means that this one has to be 90 degrees. So I'm going to take 4x minus 18 and set it equal to 90. Adding 18 to both sides, I'm going to have 4x equals 108. And then lastly, if we divide both sides by 4, 108 divided by 4 should give me an answer of 27. Again, it just asked me to find the value of x. It didn't ask me to find anything else. So again, I'm done there. Okay, if Lowell Avenue runs parallel to Carlton Avenue and Islip Avenue runs parallel to Carlton Avenue, what is true about Lowell Avenue and Islip Avenue? Okay, it always helps to draw a picture here. Sometimes these problems can get a little wordy, so just draw a picture. Okay, so Lowell Avenue is parallel to Carlton Avenue. So let's say that that is Lowell. And that's going to run parallel to Carlton. Okay, those two are parallel. And then we have another one. Then Islip Avenue is going to run parallel to Carlton Avenue. So that means these two are parallel. Then what's true about Lowell Avenue and Islip Avenue? So what's true about this top one and this bottom one? Again, they're both parallel to the same line, which means that they're going to be parallel to each other. So they are parallel. Okay, again, pretty much kind of seems obvious, but sometimes the obvious is going to be the key to figuring some problems out as we get later in these chapters.